In this session, we will cover superelevation and the creation of superelevation shapes. Our objectives in this particular class are to generate superelevation shapes using either the automated superelevation tool or the auto shape builder and apply these shapes to a roadway. And we'll look at both of those tools during this session. Introduction. Geopak supports options for defining pavement on proposed cross sections, and that's exactly what the shapes do, is they will define the top surface of the pavement. We can do this from just a simple cross slope from a center line, or all the way up to complicated multiple roadways where you have different cross slopes and widths. So let's get into a MicroStation file and look at the Superelevation tool. We're going to access Superelevation from Project Manager, so we'll open Project Manager. We'll select our project. The Project Manager toolbar opens, or toolbox opens. And you'll notice that we have two buttons. One button is Calculate Superelevation, the other one is Superelevation Shapes. So Calculate Superelevation will calculate superelevation from beginning to end without any variations. The Superelevation Shapes, which we'll look at a little bit later, will allow you to go out and create your own superelevation shapes based on information that you may need for instance, left turn lanes, mailbox turnouts, or bus turnouts, those things that are not a standard straight up and down the road. Then we will create those shapes by hand using the superelevation shapes. But the first thing we're going to do is go into Calculate Superelevation. We'll select that. We get our run box, which gives us a variety of, we can go in and create different scenarios if necessary. In this case, we're just going to use the Untitled. Move this box out of our way, and we have our superelevation box. The first thing we need is the job number, which is placed in here, job 200. We need to define a chain. We're going to use main road. It goes out and reads the GPK file and gives us our beginning and ending station. We need to set up a design speed, and we'll set up 35 as our design speed. Now, you'll notice down here we have preference files, and where those preference files are located or come from in the case of the default preference files is in the bin directory. So if we go to File, first of all, we can see directories, and it shows that all the paths to these default files are in the bin directory, the Geopak V8 V8-11./bin. Now, you may have these files, and the files that we are talking about are called SEP files, Superelevation Preference files, and they will probably be located on your server, so that is the path that you would put in these locations. Once we have that path set up, then we can go in and select whichever superelevation preference file we want. In this case, we'll choose the latest. We have 3 for English, 3 for metric. We're going to choose the English 2004, and under E selections we have all of the max superelevations available, 4% through 12. We have the facility, what type of facility it is, either divided or undivided. In this case, it's undivided, and then the L is all cases. Now, we can go in and define left and right side. We're going to go in and put in our DeskPro, our profile, which is DeskPro is our design profile. The offset we have is going to be 0. It's right down the center of the alignment. Now, we have the same on both sides. We can go in and set these up by selecting this button, New Lane. It will give us information or give us a box and let us go in and set it up. Or we can go in and utilize this button right here, which is called Quick Entry. And what quick entry does is it allows us to go and select the facility as undivided, the lane width, the total number of lanes, and in this case we're going to give it 4 lanes, and the nominal percent of slope, in this case is -2%. And we're going to say OK. Once we accept this, it puts that information in the field for us in both left and right. Now we see dependent, and only one of them is dependent. There are 2 types of shapes, one dependent, one independent. The dependent shape will get its information from the PGL, or the center line. That's where it derives its information or its intelligence from. The independent shape will be adjacent to the dependent shape, and it will get its information from the dependent shape. So the dependent shape will get its information from the PGL. The independent shape will get its information from the adjacent shapes. So once we have this information in here, once we have this all in here, before we go on and go any further, we're going to open up File and Preferences. Now we looked at directories. That just gave us where these files were located. But if we go into Preferences, you will see that it brings up that 2004 SEP file and gives us all of the pertinent information as far as runoff length, tangent runouts, the adjustment factors, which in this case they have adjustment factor for multi-lanes. Some agencies do, some agencies don't. The distribution, the runoff length only, or the tangent runout plus the runoff length. The rotation can be either about the center line or about the inside edge. In this case, it's about the center line. And the reverse curve information, and compound curve information, and short curve information. So all of this information is set up in that SEP file, and it can be modified. This can be modified, and we would just say save. There is no OK button or close. It's just, we're just going to close that file, and that is where this information comes from, and all of the information needed to calculate the superelevation shapes. Once we get this information entered, we go in and set up or give it a input file name. And in this case, we're going to call it shapes.inp. Whenever this file is created, it's going to be created and placed in our working directory. Now all we have to do is say generate superelevation transitions. When we select this, it automatically generates a file, an input file. It gives us all of our information, the project name, the shapes.imp, what input file it is, the log file. We're using 6% max. Then it gets all of our information here from main road, the profile, -24 to -12. It lets us see where this information starts and where it ends. Now you'll notice that all we had listed, or all we had chosen before we ran this information, was our travel lanes, the 24 feet or the 2 12-foot lanes on either side. If we needed to put in a 10-foot shoulder, for instance, on each side of this roadway, we would add that here. In other words, we don't want to add that back in the calculation phase, because we don't want to calculate the transition length based on the roadway plus the 10-foot shoulder or the shoulder. The superelevation transition lengths are based and calculated only on the travel lanes. So if we want to add a 10-foot shoulder, we could come in to our input file and add 10 feet here, would make this 34, and go to the other side and make this 34 also. So we're actually just extending this shape out another 10 feet at the same slope. Once we have changed those, we need to come up and say File Save, which saves that modified information. We go down to the bottom, we will see that these superelevation shapes will be placed in a file called shapes.dgn, which is the file we're in. And I'm going to come up to the top, and this little looks like a drill, create superelevation shapes. And what this tool is going to do is it's going to read this input file and create our superelevation shapes. So if we select it, it has created our shapes. Can close this information out. We'll save those parameters and we'll do a fit, and there are our superelevation shapes. If we go to View Attributes, we can turn on our fill, and we will see that we have our shapes created. We can turn the fill off. And you'll notice that now we can see our different shapes. You can see how we have a 24 here, or a 12 foot here, 12 foot shape, a 12 foot plus our 10 foot extension. We have our 2%, and then it goes to our full super at 4.8. So now that we've created our superelevation shapes, let's look at another tool. And the other tool that we have that we can utilize for in conjunction with our shapes, we'll look at the information we have right here. We have automated superelevation, which is what we just got through doing. We have the auto shape builder, which is what we just used to execute the drawing of these shapes. We have shape maker. The shape maker is what we will look at shortly to draw shapes that represent like left turn lanes or mailbox turnouts by hand. We have a shape analyst. If we choose the shape analyst, we have our job number. We can do this for display only. I'm going to go zoom in here so we can see this a little better. When we open that shape analyst, we get what's called the shape manager tools. And we can select our chain, which is main road, and we can either do DP or do dynamic. DP will allow us to come over here and hit a data point in a particular location. It gives us the chain, the profile, the station. It also gives us an offset, an elevation at that point, PGL elevation, PGL slope, cross slope, longitudinal slope, and flow slope. So this particular tool gives us a tremendous amount of information about that particular shape. If we do an update screen, since we are using display only, that will go away. If we go to dynamic and we go into the screen, hit a data point, as we move, you'll notice that it changes. As we move, the information changes. If we move across this line into another shape, it will still maintain the ability to give us information as long as we are in a shape. You'll notice as we get closer to our full super, the cross slope is -8. Now we're going down back towards our -2%. So this allows us to go at any location along the shapes and find out this information. We can also do it by station and offset. So it allows us to do it by a particular station and offset, and it'll give us that information. And you'll notice that it had this information in here when we selected by station offset, and it gave us that information here. We also have a shape profile, which will give us a profile of the shapes and allow us to draw that information on the screen at increments. We have a shape editor. The shape editor will allow us to go choose a particular shape. We choose this shape, accept it, It gives us the beginning station, the ending station, the beginning offset, the beginning cross slope and the ending cross slope. We can actually go in and modify this and say apply, and it will dynamically change the slopes to reflect these changes. We have a shape selector, which allows us to select by symbology shape properties. If we want to see what those shape properties are, we can select all of this information. We can ID a particular shape, and it gives us all the information about that shape. If we ID another shape, it will give us that information. And we also have the ability to go in and set up, go from shapes to a DTM. In other words, this tool will allow us to create a DAT file from our shapes, which will allow us then to go in and create a TIN file from that DAT file. So let's look for a minute. Let's go in and we'll zoom out on our this particular file, and we will zoom in to an area here, and you'll notice that I've got 2% here. And what I'm going to do is zoom in on this area, and I am going to utilize my snaps, and I'm going to go near point snap, and I'm going to draw a line. Go back to my CAD tools, and I'm going to go here, and I'm just going to snap there, draw a line, just a short line out here. Okay, I've drawn 4 lines, just 4 microstation lines. And what I want this to represent is, for instance, a mailbox or a bus turnout. Now I want to add that to this shape. To do that, I'm going to go back to my tools, back to Project Manager. And in this time, I'm going to choose the Superelevation Shapes, or the Shape Maker. Move this out of the way. And before I start to make these shapes, I'm going to go back and choose my button bar, get my button bar back again. And I'm going to choose a parallel button, and I'm going to select Place Line command. And we'll snap to this line and draw a line perpendicular from that line across this area. Now, the reason I'm doing that is because this particular line, it will be called, it's what we call a filler line. And what the filler line does is it represents the cross slope, and we want that cross slope to be perpendicular to the adjacent shape or the center line. We don't want that at an angle. It is perpendicular to the center line. So this particular line will define the cross slope, which is a -2%, and we're going to create 2 shapes. Those 2 shapes, one will be on this side of that line, one will be on the other side of the line. So now that we've done this, we're going to go in and select a baseline, which is main road, select a profile, which is Desk Pro. We want this to be an independent shape because it does not touch the PGL. It will get its information from this adjacent shape. We want the symbology. We can change the symbology if we need to. We'll call it that. Our tie is going to be 0. And in this case, instead of by DP, we're going to choose by line, by filler line. Now, if this was in a transition area, we would toggle this on. Transition area meaning in an area that changes from one point to the next. In this case, we're not. We're in one area here that is a non-transition area, so we won't toggle it on. We're going to go in and set our slope at a -2%. We're going to do this semi-automatically, which means that we're going to walk this process through. We're going to identify the line, ID the line. We're going to select that button, come over here, select this line, and we're going to say draw. Now, when I say draw, you'll notice at the bottom left-hand corner of the box here in my prompts, it tells me to ID an element. So I'm going to ID this element. Hit a data point, it moves to there. Hit another data point, it goes to there. Data point, yes, no, yes, yes. Now, to make it move around the area the way that I want it to go, I simply use the data point to get it to go to the next location. And if it goes somewhere that I don't want it to go, I will hit the reset until it does go where I want the circle to go. Once it completes this, I will hit a data point and it will create a shape. I will do this. I'm going to do the same thing on the other side. I'm going to say ID the line, select it, say draw, identify the shape over here, accept it, say yes, no, reset, reset, yes, 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 no, yes, and yes. And now I've created, and I can go in now and delete these lines, delete the filler line. I don't need that anymore. I've got a shape here that has a 2% cross slope and a shape here that has a 2% cross slope. So once I've done that, whenever these shapes are used in conjunction with my proposed cross sections, I will see a widened area here still at the 2% slope. So we can do that in a, once again, in a non-transition area or in a transition area. The only difference in a transition area from this non-transition area is that instead of a filler line being in the center of the area, we would have a filler line on each end of the area, because this end, the slope at this end will be different from the slope at the other end. So we will be transitioning from one slope to the other at the same rate that it's transitioning in the adjacent shape. So that concludes our session on superelevation shapes.